what we're starting with 4, 5, and 4, 6 is solving polynomial expressions, polynomial equations, solving these higher degree polynomial functions. And so far, we have 4 main ways to solve it. We have factoring, graphing, completing the square, and the quadratic formula. Now, the quadratic formula and factoring really are, for us at this point, are going to be focused more around quadratics than they are anything else. Because we had to kind of skip just due to time constraints with 4, 4, because we skipped 4, 4 because we did synthetic division, long division in 4, 4, or 4, 3, and then we skipped straight to 4, 5. The main reason that happened, well, we don't have time between now and Christmas break to be able to cover it all, so we're going straight to solving. We will come back to factoring when we get back from Christmas break. And I was planning on doing factoring anyway. So these are the 4 main ways. But the biggest thing with solving is we need to get solutions. And we're going to find lots of ways to get solutions. And if we can get n minus 2 solutions, where n is the degree, so whatever the degree is, if we can get at least or almost the number the same as the degree, so if the degree is 5 and we can get 3 solutions, that's the best, that is the minimum of what we need to do. Best case is that we get number of solutions equal to the degree. If we can get the number of solutions equal to the degree, that is the best case scenario. So, we're going to look at this first problem here. Now, the first 2 that we do, we're actually going to solve these by factoring. We're actually going to solve these by factoring and factoring these out. So, when we solve by factoring, the first thing we need to do is get the equation equal to 0. As if we can get the equation equal to 0, that's going to be very helpful in solving this here. Now, if we notice for this one here, 2x cubed minus 12x squared plus 18x is already equal to 0. So we don't have to do anything to get it to be equal to 0. It's already there. So the next thing we're going to do is look for a greatest common factor between these 3 terms. We need to see if there's a number or expression that can go into all 3. And 2 does go into 2, 12, and 18, yes? So we can factor 2 out of all 3 terms. Now, x cubed, x squared, and x do all share a common factor of x. So actually, the greatest common factor between these 3 terms is 2x. And we can factor it out. So if I factor 2x out of 2x cubed, the 2 divided by 2 simplifies. And when I remove 1x out of x cubed, we're left with x squared, because we have 2 of them left. Now we factor 2x out of negative 12x squared. Well, we still have the negative. 12 divided by 2 is 6. And our x squared divided by x is just x. And lastly, when we factor 2x out of 18x, 18 divided by 2 is 9. And x factors out completely, telling us that it's just plus 9. Questions on this so far? Now, from the original problem, factoring 2x cubed minus 12x squared plus 18x, we did not have a way to factor, just as it is as that whole. But by factoring out that greatest common factor 2x, it now gives us something that we can actually factor. So now we can do our two sets of parentheses with three spaces and then look for the sign. Now because the third term, if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. But because the third term is positive, our signs are the same and match the sign of the middle term. Excuse me, so we'd have negative and negative. Now we need to find the factors of the first and third terms. Well, our x squared's factors are x and x. Now we don't normally write out the factors of x squared because there's only one set of factors of x squared that actually work for factoring, and that's x and x. So we don't necessarily write that out because there's only one set. Now our factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And before we move on to our next step with solving, we do want to make sure these are the correct factors for our x squared minus 6x plus 9. Now we don't check the x times x, because x times x is x squared, and the reason we got x and x is from the factors of x squared. By definition, they will multiply back together to give us x squared. We also don't multiply the negative 3 and negative 3 because, well, negative 3 and negative 3 are factors of 9. They will get us back to positive 9. The one we're focused on is the middle term. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is indeed negative 6x, which is the middle term we wanted, yes? And the reason we're doing all this is to get an expression where we have two or more things multiplied together that equal 0, yes? And we do have that, and it has to be 0. Because here, since these three expressions multiply together equals 0, it means that either 2x is 0, x minus 3 is 0, or x minus 3 is 0. Now, if we said for some reason that it was equal to 8, we didn't get it equal to 0, don't write it as 8. The number of, we'll just say two terms multiply together that gives us 8. We have 2 and 4. 2 times 4 is 8. Or we can say 4 times 2. Or we can also say 1 times 8, and 8 times 1, yes? Or I can say 16 times 1/2. Or I can say 32 times, because 8 would be 1/4. There's an infinite number of ways that I can multiply two things, especially if I'm not restricted on what the numbers are, that I can get 8. So that doesn't help us, but with the zero product property, there's only one way, one main way that we can multiply any two or more things together and get 0, is if one of those is 0. The other expression could be whatever number we want, but one of those has to be 0. If it's any other number, none of those are 0. There's no way it's going to equal 0. One of those expressions has to be 0. That's the nice thing about the zero product property. Now 2x equals 0. Wait a minute. What did we just say about the zero product property? We have two or more things multiplied together to 0. One of them has to be 0. I can't do anything with 2. It doesn't have an input. It's just number 2. So the only part of that that could be 0 is x. Or I can divide both sides by 2. 2x divided by 2 is just x. 0 divided by 2 is, well, 0. We get there either way. X minus 3, if we want to solve this here, we need to get x by itself. So we'd add 3 to both sides, telling me x is equal to 3. And incidentally, we'll do the exact same thing with the other x minus 3. Telling us x is also 3. So our solutions for this here is x is equal to 3, x is equal to 3, and x is equal to 0. Yep. So we have 3 solutions for this here. Questions on this here? Are you ready for the next one? 5x cubed minus 40x squared plus 80x. So if we're going to solve this by factoring, I would first look for greatest common factor between these three terms, because we have no other way to factor this if there is no greatest common factor between these three. Well, 5, 40, and 80 do all have a common factor of 5. X cubed, x squared, and x have a common factor of x. So we can indeed factor 5x out of all three terms. Interestingly enough, because of this being the greatest common factor, we already know what one of the solutions should be. 0, because our 5x is going to have to be 0, so x is going to most likely be 0. We'll check and make sure here in a minute. But first, we need to factor 5x out of all three terms. If we factor 5x out of 5x cubed, we should get x squared. If we factor 5x out of negative 40x squared, we should have negative 8x. And when we factor 5x out of 80x, we should get plus 16. Questions on this here? Now at this point here, we'll factor the x squared minus 8x plus 16. Since the third term is positive, the signs are the same and match the sign of the middle term. If the third term had been negative, the signs would have been opposite. Factors of x squared, we only have one set, x and x. 16, on the other hand, we have a few sets of factors. 1 and 16, 2 and 8, 4 and 4. 2 plus 8 is?
10.
And we need it to be 8. Now we can check and make sure, because we could have tried 2 and 8 and it would have given us negative 10x. Here, x times negative 4 would be negative 4x. Negative 4 times x is negative 4x. And negative 4x minus 4x would give us negative 8x. Now normally I would go through with it, but for time's sake, we're just going to get 4 and 4. Now again, we could check. That's the main reason we do check. Is just to make sure we do have the correct factors and not just pick the two, assume they're correct, and move on. We want to verify. So we get 5x times x minus 4 times x minus 4 equals 0. And according to the zero product property, either 5 times x, 5x, is going to equal 0. X minus 4 is going to equal 0, or x minus 4 is equal to 0. One of these has to be 0. Now, the nice thing with 5x, we do have two things multiplied together to equal 0, so one of them has to be 0. So we could say just x is equal to 0 because it's a zero product property. Or we can divide both sides by 5. 5x divided by 5 is x. 0 divided by 5 is 0, telling us x is equal to 0. Now, to solve x minus 4, we would add 4 to both sides. On the left-hand side, x would be by itself. That's not what I said. 0 plus 4 is 4. We simplify both sides, so we get x is equal to 4. Incidentally, we're going to do the exact same thing with the other one. Add 4 to both sides, and it tells us again that x is equal to 4. So x is equal to 4, x is equal to 4, and x is equal to 0. So 0, 4, and 4. So we have 3 solutions. Even if we do have repeated solutions, we do count them a part of the total number. Questions on this here? We good with this so far? We're ready for the next one. Find the zeros if f of x equals negative 2x to the 4th plus 16x squared minus 32. This is actually factorable. This is factorable. It's a quadratic-like equation. So we could almost factor it the same way that we've been factoring these quadratic equations. And that's really what we would have focused on in 4.4. But what I want to do for this here is I want to graph it. We want to graph this function. So we need to make sure everything's on the same side. It's equal to 0. But since it is in function notation, we just need to make sure everything's on the same side, which it is. Now at this point here, I'd grab the graphing calculator. And we're going to hit y equals. If there's anything typed in there, we want to clear it out. And what we're going to type in is x negative 2, x to the 4th. Plus 16x squared minus 32. Negative 2x to the 4th minus, or negative 2x to the 4th plus 16x squared minus 32. Were we all able to get that typed in? So the caret key, it's the button above the division symbol, or our division button. Yep. Once you get it typed in, hit graph. Looks like this here, yes? So, again, we're looking for what values of x will make the y value be 0, where it crosses or intersects the x-axis, yes? And it looks like it is 2 and negative 2. Now, to verify or make sure, we can go second graph. We can look at the table because it gives us the x, y values. When x is negative 2, the y value is 0. When x is 2, the y value is 0. Okay? Oh yeah, this is for some reason. Seven, 1, 2. There we go. It was working, but something was turned on preventing it from actually looking like that. Hit y equals. Oh, okay. So those, yeah. Type in the whole equation. There we go. You're welcome. So we write the solutions out. We could write it as x equals 2, and then x equals negative 2, and x equals each time. Or we can put commas. So we can say x equals 2 and negative 2. So we can list it out instead of rewriting x equals multiple times. We can separate those solutions with commas. Also works. Okay. Now to find the rest, we're going to use synthetic division. Because when we divide, and if you notice what we did last week with dividing, that the degree of our solution and what we got after dividing was 1 less or 2 less than what we started with. What we're doing is we're removing those solutions, we're removing those factors from the equation, making it easier to solve. So what we're going to do is we're going to take the starting equation, negative 2 for x to the 4th, 0 for x cubed, 16 for x squared, 0 for x, and negative 32. And we're going to divide it by each of our solutions. Which one do we want to try first? Negative 2 or 2? Negative 2. And let's do the synthetic division. So negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 16 plus negative 8 is, well, 8. Negative 2 times 8 is negative 16. 0 plus negative 16? is negative 16. And lastly, negative 2 times negative 16. Well, a negative times a negative is going to be a positive. 2 times 16 is 32. And negative 32 plus 32 is 0. And that's what we wanted. Because what we had Friday, the remainder theorem. So it said, the remainder theorem said, whatever the remainder is would be equal to the same number as if we plug that value into the function. And if it is a solution if, when we plug it in, its value is 0. So therefore, if the remainder is 0, it is a solution to this here. So negative 2 works. What number can we do next? Well, what's the other solution we got? 2. Now, some books will say that we rewrite it. We reset the problem up right below. We put the cubby. We rewrite those numbers down below it. But I think it's set up quite nicely just to do it again from where we're at. I don't want to rewrite the whole thing. So I'm going to put a cubby, put our other solution in, and do this again. 2 times negative 2 is negative 4. 4 plus negative 4, 0. 2 times 0 is 0. 8 plus 0 is 8. 2 times 8 is 16. And negative 16 plus 16 is 0. That's what we wanted. We want a remainder of 0, because if we have a remainder of 0, it is telling us, it is confirming that it is indeed a solution. Do we have any other solutions that the graphing calculator gave us? No. But you don't have to put this in. If we looked at the variables, we started out with an equation with degree 4, yes? So you don't have to write those in. I'm just kind of putting them there so we can see. Our next equation, negative 16 was our constant term, our term without x. 8 was our term with x. 4 was our term with x squared. Negative 2 was our term with x cubed. So we now have a cubic. We did the division again. So where we're at now, 8 is our term without x. 0 is our term with x. Negative 2 is our term with x squared. We now have a quadratic. We have lots of ways, or several ways, to solve quadratics. So at this point here, our remaining equation is negative 2x squared plus 8. And you can write this right underneath it. You don't have to put it to the side. We just need to solve this here, because that's the equation that we have remaining after doing our 2 divisions. So we need to solve for the remaining solutions. Now, the nice thing with this equation is we don't have an x term. We don't have x to the first, which means we can use the square root method. Since we just have that x squared as the only variable, we get it by itself, take the square root of both sides. So the first thing we can do here is subtract 8. So we have negative 2x squared equals negative 8. Then we'll divide both sides by negative 2, telling us x squared is equal to 4. Yes? We good on this so far? Last thing we need to do is take the square root of both sides. Now the square root of x squared is x. Now when we take square root of both sides, we have to put plus or minus. And the square root of 4 is 2. So that means our other 2 solutions are positive 2 and negative 2. We can list it out as plus or minus. But our solutions are 2, negative 2, 2, and negative 2. So we have 4 solutions. We really have 2 repeated solutions, 2 and negative 2. Questions on this here? Yes, we could have probably tried 2 and negative 2 again. Because one of the interesting things with the graph of a polynomial function is it actually does give us a little more information than we might think. Because whenever the graph of a polynomial, higher degree polynomial function, touches the x-axis but does not cross it, It has an even number of 0. It has an even multiplicity. So at those two locations, we could have 2, 4, 6, 8, 10 number of solutions at that point. So at 2, we could have 2 2s as solutions. We could have 4 of them. We could have 6 of them. We could have 8 of them. So if we notice that it touched the x-axis but did not cross it, I could come down here and say, I'll remove these here. I could try positive 2. Again, you don't have to write this. You're going to have to fill it in. 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8, and it does indeed give us 0, yes? Well, what did we say the other solution was? Negative 2. We could try it again. Negative 2 times negative 2 is negative 4 plus 4 is. So it tells us it's a solution, yes? What is our remaining expression? Negative 2. It's not an equation anymore because we do not have a variable. We wouldn't list that as a solution. So it's just a constant term. So that doesn't really mean anything. But if we wanted to, what we have now, because if I fill the variables in now, because now I have negative 2 x minus 4 equals 0. Oh, wait a minute. That's a little bit easier to solve, isn't it? We can add 4 to both sides, knowing this negative 2x is equal to 4. Divide both sides by negative 2. I don't know what it did, but I know I freaked it out. Okay. Yeah, it really freaked it out. We can divide both sides by negative 2, knowing this x is indeed equal to negative 2, which is what we found, yes? So the more solutions that we find, the more synthetic divisions that we can do, the easier the last solving is going to be. Questions on this here? Let's look at this one here. X to the 4th minus 18x squared plus 81. Again, we haven't gone over ways to factor this or solve it, so let's just graph it. So I'd clear that out, and I'd fill it in. So we'd have what? X to the 4th minus 18x squared plus 81. So once we get it typed in, we're going to hit graph. And for a good bit of this here, especially for this next test, it's going to be very helpful to be able to graph these. To be able to type these into the graphing calculator to graph them, because this is how we're going to find a lot of our solutions. So we do see it intersects the x-axis in 2 places. Second graph tells me that the values of x that make this function equal 0 are 3 and negative 3, yes? So we can come back over here. I know x is equal to 3, comma, negative 3. Now, it does look like it intersects the x-axis but does not cross it, so there's a good chance that there's an even multiplicity. There might be an even number of zeros at that spot. But to make sure, we're going to set up our synthetic division and solve that way. Because there might be other zeros outside of it. We just need to make sure. Now, do we want to use 3 or negative 3 first? Doesn't really matter. 3. Now we're going to do our synthetic division process. And we want the remainder to be 0. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 18 plus 9, negative 9. 3 times negative 9 is negative 27. And 0 plus negative 27, well, is negative 27. And 3 times negative 27 is negative 81. And 81 plus negative 81 is indeed 0. And especially going into that last one, don't just assume that they are equal. I would still make sure we do the calculations. All right, what number do we want to do next? Negative 3, because that is one of the other solutions we got, yes? 3 times negative 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. Negative 9 plus 0 is, well, negative 9. And negative 9 times negative 3, the negative and negative would make a positive.
It's negative 27.
Negative 27 are just 27, because our negative and negative make a positive. So 3 times 9 is 27. And negative 27 plus 27 is indeed 0. Now at this point here, if we went and filled the variables back in, we would have had x squared plus 0x minus 9. And we can say x squared minus 9, yes? But we did notice that at 3 and negative 3, the graph of the function intersect the x-axis but did not cross it. It touched the x-axis but did not cross it. So there might be a chance that we have an even multiplicity of zeros at that location. So there might be an even number of zeros there. So what can we try and see if it does work? What could it be? It could be. Take a guess. 3. Because we could try 3 or negative 3. Because if it does give us a remainder of 0, it means it is a solution again. Because as we do each one of these here, we're removing that solution from the remaining equation. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. And negative 9 plus 9 is
0.
So was that a solution? Yeah. Now at this point here, we can plug the variables back in. Because now our remaining expression is x plus 3. So we can set it equal to 0 and solve. So we would subtract 3 from both sides, telling us x is negative 3. So the synthetic division told me that positive 3 showed up twice. And then using the remaining equation, we now see that negative 3 shows up twice as well. So the solution is negative 3, 3, and 3. The order in which we write the solution doesn't matter, as long as all 4 are listed. Questions on this here? We're starting to see what the goal is with this here. It's finding at least n minus 2 solutions where n is the degree. So with the degree 4, we really need at least 2. If we can find 2, it makes it easier to solve. If we find enough solutions to get it to a quadratic or smaller, we're golden. We're ready for the next one. I'm going to skip the actual next one, and I want to go to this one here. 2x to the 5th plus 24x equals 14x cubed. Now again, with solving, the first thing we want to do is get this equation equal to 0. Before we even graph it, we need this equation equal to 0. I'm going to subtract 14x cubed from both sides, because A side with 14x cubed has one term. The other side has two. I would rather move one thing than move two things, because we knew it equals 0. Subtracting 14x cubed would get us 0 on the right-hand side. And once we get it equal to 0, our default, and what we'll probably do for the rest of this chapter and most of this, and it's a great way to do it, is utilize this graphing calculator, hit y equals, and let's type it in, let's graph it. 2x to the fifth minus 14x cubed plus 24x. We want to type this in and graph it. So we have this here. We see where it crosses the x-axis, yes? -2, 2, and because it crosses 5 times, yes? And really, we need 3 solutions. If we can get at least 3, and 0, because we're looking for what values of x makes the y value be 0. At -2, when x is -2, its y value is 0. When x is 2, the y value is, and when x is 0, the y value is 0. So we're looking for whatever values of x makes the y value be 0. So we have x is equal to -2, 0, and 2. Now, interestingly enough, we did see that it crossed the x-axis 2 more times, yes? So we will need to find those. We need to see what those solutions are. So we can do synthetic division. Now we have 2 for x to the fifth. Now since we don't have an x to the fourth term, we're going to fill it in as 0. We have -14 for our x cubed term, 0 for our x squared term, 24 for our x term, yes? Do we have all of our numbers? Because again, the number of numbers that should be up there is 1 more than the degree. And what's our degree? 5, yes? So that means how many numbers should we have up there? 6. Do we have 6 numbers listed? We have to add a 0 because do we have a constant term? Do we have our term without x? Nope. Since it's not listed, it is also 0. So again, that's a good thing to pay attention to. Number of numbers up there should be 1 more than the degree, so we should start out with 6. What solution do we want to start with? -2. -2 times 2 is -4. 0 plus -4 is -4. -2 times -4, the negative times the negative makes a positive, and 2 times 4 is 8. -14 plus 8 is -6. -2 times -6 is 12. 0 plus 12 is 12. -2 times 12 is -24. 0 plus, or not 0, -24 plus 24 is 0. That's where I'm getting the 0 from, most likely. -2 times 0 is, and 0 plus 0 is 0, just like we wanted. All right, pick another solution. Which one do we want to try next? 2, +2. 2 times 2 is 4. -4 plus 4, 0. 2 times 0. -6 plus 0. -6. 2 times -6 is -12. 12 plus -12 is 0. 2 times 0 is 0, and 0 plus 0 is 0. What solution do we want to try next? So we can try 2 again. Don't write this one. I'm going to do this one up here. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. -6 plus 8 is 2. 2 times 2 is, and 4 plus 0 is 4, telling me that the remainder is, which means 2 is not a solution again. There's actually one solution that we didn't try yet. 0, yes? It seems like we can't do it with 0, but let's give it a shot. 0 times 2 is, 0 plus 0 is, 0 times 0 is 0. Yes, it feels like it's going to zero the whole thing out, but not quite. Because negative 6 plus 0 is?
-6.
0 times negative 6 is? And 0 plus 0 is? 0. Now, one way that we know that 0 is not going to work again is because the constant term is not 0. What's our constant term now? Negative 6, because the last one, that remainder, is gone. We don't take the remainder in again. So 0 is out, negative 2, or 2 is out. I'll give you a hint, negative 2 is also out. So since we don't have any more solutions, we are going to have to throw the variables back in. We have our remainder, term without x, term with x, and term with x squared. But the nice thing with this equation is that we don't have a middle term. We don't have an x to the first, which means we can use the square root method. So the first thing we can do is add 6 to both sides. Negative 6 plus 6 cancels, telling us that 2x squared equals 6. Then we can both sides by 2. X squared, 2x squared divided by 2, x squared, and 6 divided by 2 is 3. Now, since x squared is indeed by itself, we can take the square root of both sides. Our square root of x squared is x. And again, when we take the square root of both sides, we've got to put that plus or minus. Square root of 3 is?
3.
Almost. Square root of 3. So the other two solutions are positive, negative square root of 3. Now that is a good question. Can we take and do synthetic division with square roots? Yes. We can actually do synthetic division with complex and irrational terms. And it does work. It just looks a little funky, and we do have to do the positive and negative case for it to really work out fine. Because I know the bell's about to ring, but come on. There we go. If we did it with square root of 3, square root of 3 times 2 is 2 square roots of 3. Square root 0 plus 2 square roots of 3 is 2 square roots of 3. Now, square root of 3 times 2 square roots of 3, we'd multiply the radicals, giving us the square root of 9. Well, square root of 9 is 3, and our 3 times 2 is 6. Negative 6 plus 6 is? Square root of 3 times 0 is 0. It still works. But we would have to follow it up with negative square root of 3 to get the radicals to be completely gone. But we'll stop there for today. We're going to talk about the rational root theorem tomorrow. Oh, that stinks. We'll see y'all too.